Howdy, everybody. Hope you're having an amazing time whenever you are. Um, Here's my chicken scratch for the day. You guys probably, or you all probably have something along the same lines, I would imagine. But let's start with the day, and we'll go from there. I mean, it was definitely like I was like, yeah, Intcode. If you've seen my previous videos, I've been working on it before. I felt really happy and excited about it. And then part two was all like, hey, take all that code you wrote and just it's worthless because there's no way you're gonna find a number, you know, that's in the trillions to the hundreds of trillions or something like that is what I think what I calculated it to be. Well, I don't know, maybe I got the math wrong, but we'll see. Anyway, what is today's day? Chronospatial computer. The idea is you're given a computer and it works a lot in a similar way to an encode computer, but it has its own instructions. And notably, this computer is pretty small. So it works the same way where you have instructions and opcodes, and then you have the operand associated with that instruction. And then you have an instruction pointer, which is like helping you step through your Intcode computer, right? Like with most programs, you have a pointer that's like, here's the next instruction to run. And you basically just do that until you run out. Um, there's two types of operands. One is a literal and one is a combo, where the combo has these special rules, meaning 0 through 3 are just literal 0 through 3, but 4, 5, and 6 represent the letters A, B, and C. And then 7 is reserved. So there's a chance that this comes back with more instructions or changes to it, which might be interesting. As you know, I think Intcode was really popular. I've enjoyed working on it, and I plan to finish it. I think I have 2 days worth of Intcode left. I just hadn't found anything interesting to like do it in, to like make it into a video besides just solving it. So those 2 days, maybe I'll just solve them. Anyway, and then it describes the instructions. A div is like take A and divide it by 2 to the power of B, or 2 to the power of the opcode, I guess I should say. The combo instructions. Excuse me. BXL is a bitwise OR of B with a literal. BST is a modulo 8 of a value that's put in register B. JNZ is your jump instruction. BXC is your bitwise OR, but you do it with the B and C register. Out is your like output opcode, so you want to track output in this case. Notably, it says, and I missed this earlier, and I was having trouble solving the problem. It's the combo operand modulo 8. So like I was just like printing out the operand, not doing modulo 8. So that was a gotcha for me for this day. Not a big deal, just had to find the bug, right? BVD is like a div. So a div is up here. B div is up here, except it just saves the results in register B. And C div is the same as A div, except it saves the results in register C. It still uses register A. Both of these do. It just where you save it is different. And so, what is the idea of part one? They're going to give you a program that looks like this. You're going to have to parse it. I used nom in my case. And then you're going to have to get these instructions where like each of these pairs are an instruction. And then your job is to run it. That's what part one is, right? So, I mean, if you've seen some of my days before, I always enjoy this, especially in Rust, because you can do a lot of the enum stuff. So you can see here I have a register, and then I have registers, which is where like my program's memory is, you know. And you can see I parse it with nom, just like I have other days. I won't go over it too much. And then I have these getters and setters that can be used within the program itself, right? So I change values or save values based on the register stuff. The reason I did this is because I was using the enums, and so having this getter setter, I actually realized later that you can create like the bracket operands. I didn't have time to do that, so that might be a fun thing to do. I have a couple things I want to do for this day, so that might be a fun one to do. Is to turn these into like bracket operators. Anyway, I have this for parsing as well, which I used before, and then I have my combo. So again, each instruction is either a literal or an opcode depending on the instruction. And so I have an enum for the combo, and here's how you parse it, and here's how you evaluate it. So nothing crazy there. The nice thing again about matches and enums is you can do this stuff and be sure that you've like found everything and handled all the errors, right? So and then here's all the instructions, and I tried to write them out based on, you could see I was like doing comments of like what they did and what they looked like. For part one, I was just like kind of going through this. You actually see a pattern if you spend enough time looking at them and your own program. I guess I don't know if everyone's was the same. I presume it's probably close, just with different numbers. Anyway, we'll talk about that in part two. But then, how to create an instruction. And then I have a computer which has all of it, right? So it has my registers, it has my instruction pointer, the list of instructions to run, and like the output. Because for part one, the output is the important part, right? Here's my parser. I just use num, nothing crazy. And then, I do some code to like turn my list of things into instructors. This chunks is a pretty cool thing. I think I don't know if I've used it before, but the idea is it's like take a big list, turn it into turn it into n chunks, in my case 2, and then I can use each chunk to call instruction new on it. So if you haven't seen that before in Rust, that's another cool one. I think I talked about this before. Maybe not. It was just in a comment. The standard template library C++ got me. The standard library is like really cool in Rust, and it's got a lot of features that you'd have to be using Rust every day for hours a day to like even know what half of them are, I think. So anyway, here's my run instruction. So eventually you've got your computer, you want to run it. What do? I just loop. I get this instruction that I want to run, and then I can match on it. And I say, okay, if it's a div, I just set my register A to that value. And this is, I'm just doing the math here, right? So it looks a little crazy. I'm doing 2 to the power of the evaluating the combo. And then that A is divided by that result. So it's a little weird math. And you actually, in part 2, I realized I don't even have, this turns out to just be like a shift operator. So you'll see that stuff later. But anyway, I'm just implementing each of the things, right? So the BXL is for bitwise XOR for B. So you can see I just do that. BST is mod 8 of the value. And again, I'm just doing all these things, right? And so you just loop through all of them. You do them. You increment the instruction pointer, notably except for the jump, right? Because if you actually jump, you don't want to change the register. Anyway, so I do all that until I've reached the end and I break. And that's really it for part 1, right? So I think the hardest part in part one was like, can you grok what is being said in the puzzle and then turn that into a computer? Again, I used a lot of enums and a lot of stuff, so you can see it's like, I don't know, 200 lines of code to get me to a solution. But it was because I was like, oh, can I use enums and can I use these things? Kind of like I had done with the Intcode before, to like, practice the Rusty style things with match operators and things like that. So, but yeah, once you get to it and you like fix the little bugs where you find like, oh, maybe I was doing the POW incorrectly, or what was my error? I think I said, it was one of these operators that I was doing incorrectly. And anyway, so you just have to figure out what you've done incorrectly, and then you can solve it. And so that's literally all I do is I say, okay, here's my input. get me my computer and my program for part 2. I didn't mention that. And then run the simulation, and then just print out the results. And that's all there is to it, right? It wants it in a comma separated list. So you can see I pull the output and I map it to a string and collect those strings and join them by a comma. And that gives me my answer here for part 1. Not too hard. Part 2, substantially harder. What does it say with part 2? It's like, oh, well, it turns out that your program is meant to actually output a copy of the program. And I don't know if you've seen these before, but these are actually really cool ideas. Is like, can you write a program that will output itself? It's like a self-sustaining one. They're really cool. I can't remember. There's some name for them, but it's really cool. And what it's saying is the initial value of A in your input is incorrect. So here, this is my initial value of A that got me to this answer, and it says that's incorrect. It just doesn't work. And what they want you to do is find an A such that the program prints itself back out. So what you get is you change the value of A here, and you get back, or the output of that computer program is this program right here. That is, the original program is the same as the output. Hopefully that's clear. I don't know if I explained that right well, but essentially you're going to change A until your output is equal to this right here, your program. And it says, hey, if you copy this one, you get this value. So that's actually what I did to start with. I did it in a for loop with the test, and I said, hey, can I find this value? And I went for 117, and it found it, right? It said, hey, can I just increment A a bunch of times until I get to this thing? And boom, I solved it. So I tried on the input, and it was running for like a minute or so, and I'm like, okay, there's got to be something wrong. What's the matter? Why isn't this working? So what path should that lead you down when you're like, okay, the brute force is not working? And this one was like okay, so because I've seen days like this before, I immediately went to, I need to inspect the program. But here's the intuition that like should be going through your mind, I think, in when you're looking at these problems. It really doesn't, if you think about it, it doesn't give you any details of what the solution might be, and why just doing a brute force search doesn't return after like a whole minute. Sorry, I had a little interruption there. But the idea is, you should, when you see a thing like this that's really vague, that just says, oh, we just want you to find another value, but that value is like clearly not solvable with a brute force. Like, there's no hint in here that would tell you, oh, if I make some change to my computer, my Intcode computer, I can find the answer really easy, right? And so that's where you should immediately go to, okay, well, I guess I have to start figuring out what the program does. And so I actually just started doing that, and that's what all this junk is, right? Maybe I can find where I started. It was over here. So at first I like spit out the program. So this is my program. It's BSTA, BXL3, blah, 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 all the way down. And so what I started doing was like actually like trying to turn this into a program. And so you can see what each of these instructions do. It's B equals A mod 8, B equals B XOR 3, C is equal to A over 2 to the B, B is equal to B mod C, B is equal to B mod 3, A is A divided by 8, and then you print B, and then you go to the start as long as A is greater than 0. So what is the net effect of imagine like what's going to happen is you have some A value right here, and then you can like basically you're going to run this program until it finishes. And if you look at what the program does, it's actually kind of a while loop, right? So yeah, it's right here. Basically, essentially I say while A is greater than 0, that's what this part right here is doing. And so it's like while A is greater than 0, you're doing this block of code right here. And you just keep doing that until you get to where A is 0, right? So eventually you're going to hit 0 and the program will finish. So then what's happening here in the middle? And that's what you have to think about is you have some value A and you mod 8 it, right? And this is where I think, you start to say to yourself, oh, is there some bit stuff that's going on here? So think about what's happening here is A mod B is essentially saying take the last 3 or the first 3, depending on how you think about it, the bits of A and set that to B. So you've got some large chunk of A. So this is A, and you want just this last part, and you're going to set that to B. And then you're going to say, now I want to do a B XOR 3. Why do you do an XOR 3? I guess I don't, I think I tried it. I looked over here and was like, what is actually happening here? And you can see I actually wrote them all out to try and get an idea. But essentially what you're doing is adding 4, at least in my case. Again, I don't know if everyone's program is the same. We'll have to go look and see. But, I did look at some. I was trying to do like a Z3 solver after this, and I did look at some, but I guess I don't remember if they were exactly the same. I was trying to figure out how to use Z3 solver to do this, and I didn't never figure it out. Anyway, but I guess I didn't pay enough attention. We'll have to go look and see. I don't know how similar the algorithms are, so we'll have to go look. Anyway, the point is like you set you set B to the last like few bits of A, and then you do this XOR of it, which is like you basically add 4 mod 8, right? So you can see here you start with 0 through 7, and then you actually go from 4 to 3 now because you mod over right here, right? So you're doing that, and then you set A to this. This is what A is. A is actually shifted B by that 0, 11, that 3. And that's what occurred to me is like, oh, like, can you see what's actually happening here is like you are shifting, you're interested in like this value and like this value, or is it this value? I don't actually remember. Like what you're doing is you're interested in these. It can change. I actually think it changes based on where you are. But like the idea is you're basically performing operations on like the lower bits for this section, right? It's like you take 2 bits and you do an XOR of those bits, right? So that's where I'm like, oh, B is the last 3 bits of A, mod this shifted value of A, right? There's 2 little chunks, 3 bits of those chunks of A that you're using in your loop here. And then what do? You just cut the last 3 bits of A off. So A mod 8 removes the last 3 bits, or A divided by 8 removes the last 3 bits, right? So the idea is you're gonna work on this chunk, and then you're gonna throw it away, and then you're gonna work on this chunk, and then you're gonna throw it away, and then you're gonna work on this chunk, and you're gonna throw it away, and you're gonna just keep doing that on and on until you've worked on all the chunks of A and it's gone, right? And notably, so because the last one was actually really tricky to me. I'm like, how do you get the last one? Well, the last one, A is going to be between like 0 and 7, right? And so this one where you shift it, right? It's just going to be, you're going to shift C to be a bunch of zeros. And so B will just be, it'll just be this value, I think is what I figured out. Anyway, the point of all this is to say, I realized I could actually write a program to do this, right? We can do these operations extremely quickly. And not only that, is we can how do I describe this? You actually don't care when you're working on this B, this B right here, like when you're working over here, we just don't care. We never use the rest of these numbers, right? They just aren't used. And so you really only need to like build up from these values. And when you're over here, by the way, when you're over here using this chunk, you actually don't care about these ones either, right? Those are pointless. So you can actually do this in a series, and you can actually just say, okay, well, I just want to find an A for, I want to find some A for, uh, how do I say this? I want to find some A and B such that, no, it's not A. I want to find some A that when how do I describe this? Okay, here's the way the solution came to my mind was, um, if I'm only interested in like this part of the program, and I know that this part should produce the number 0, and this part should produce the number, I don't know, 5, and this one should produce the number 7, right? I only need to find a value for A uh with which is like this chunk up here, plus some B value. I mean, it's like the A itself, but I think I called it B in here. Plus some B value, but the B notice that the B value here is mod 8, so I only have to actually test 8 cases, and like that's the important intuition is like, the B value itself can only be 8 cases. And so if I just maybe I don't know exactly what this is, but if I can test these 8 cases with some existing A stuff over here, I can eventually find my way to a solution. And the idea is you will eventually you will start branching, because there's some values of like, maybe I call this, I probably call this the funny name, but there's like some values of this A, this part of A, that will work for more than one of these 8 cases, right? Like if you think about what the work that's happening here, um it's quite possible that you could say, oh, there's a 0 and 5 works or something like that, right? For this case. And so now you actually kind of branch and you need to test both those cases. But so it does grow based on the number of ways that you can solve A plus B. So you go from like, so the first time you maybe only do 8 cases, but now you need to do test 0 and 5 for all 8 of their cases, right? So these all have 8 cases, these all have 8 cases. Maybe some of them only have 1, but because the program is so small, this size, if you're only testing 8 cases and maybe only 1 or 2 of them are getting you there, eventually you're going to get to a case that works for all of them. And once you get one that works for all of them, right? When you get up there, when you get up here high enough where you're testing almost all the values, very few of them start to actually work, right? In fact, none of them. And so I actually found that once you found a single solution after kind of working your way up, you found the actual solution, at least in my case. So let me show you how that code works. Oh, I should say I actually did some looking when I was running the program, and it took more than a minute. I was like, why is it taking so long? And it was because I figured that in order for you to get, where is this? In order for you to get 16 values, I say instructions here, but it's actually 16 values. Like the minimum to get to 16 values is like, what was the minimum? It's like 7. So what would it be, like to the 8 to the power of 8? I did that wrong. 8 to the power of 8, which is like this number right here. Like that's the minimum number, at least for my solution, that you could ever get to that, right? And so that's why I was never going to get to it. Even if I was like, I think I maybe at one point tried to use a par iter to just find a solution. But at 30, I think it's 100,000 million billion trillion. At 35 trillion, there's no way you'd ever get there. And this number, 285 trillion, gets you 17 instructions. At this number, you get 17, and so you'd never want to go about that. So if you were actually doing a brute force search, you could search between these two numbers, but that's like seriously an absurd number to catch there, and that's why you just not ever do it. Okay, so how do I solve it? Let me show you the code based on that intuition. Here's my find register program. I basically just say, hey, find a register A that will fit this program. And then if I find one, I can print P2. If I don't, I print no solution. I did this because I think I told you before, I also tried the Z3 solver. I could never get it to work, though. But here's the code right here. So what does it do? I start with a stack. Remember, there's a chance, I'm kind of doing a depth first search of this thing. So like down here in the lower cases, it could be like there's multiple values that could return, right? So maybe it'll say, oh, 0 and 5 work in your case. And then, 1, 3, and 4 work here, and 5, 7, and 2 work here, or whatever. And so you want to keep a stack of work to do. And I use a stack because if I've ever found one of a higher depth, I want to check that one first, right? So I'm doing a depth first search in this case, right? Anything that's gone further into essentially what I'm doing is I'm like trying to find a program that will just output a 0. And then I'm trying to find a program that will output a 3 and then a 0. And so if I've ever found one that's way down here that will print out all of these, I'd much rather try and solve that one than try and solve one that's way down here, right? That's down here. Maybe it doesn't end up being the case, but I'm more likely to find a solution if I pick the ones that are further down the line, right? And so that's what I do. I have this stack. I get the stack. Notice I'm starting at the end, right? I start at the end because the way the program works is it's taking like the end values last, and so it's like dividing by 5. And so these two are being outputted by the smallest values of A. And since I'm starting A at 0, I want to try and get these smallest values first, right? If I wanted to, I could potentially start. No, I don't think you could, because we don't actually know what the maximum value of this is. I don't think this is exactly correct. I just know that this one got you to 16 or 17 instructions, but mine was only 16, right? Anyway, that was my intuition, is like I start at the back because that's where like my initial smallest value of A is, right? So I'm just going to check. I'm going to do a check very first to say, hey, have I reached a depth of zero, meaning I've gone through the whole program. And if I have, then I can return that value. Otherwise, I'm going to try all the possible values for B, which is badly named now that I think about it. It's not actually B. Oh, no, it is B. Okay, it is B, because what I'm doing is I'm shifting A 3 bits to the left, and then I'm ORing B into it, right? And so I'm adding B to that. I'm adding B to the end of A. That's what this has the effect of doing. So it is B. I think I was confused there. Like this part is A, and the leftover. This is getting really ugly, huh? When I'm working on like this part of it, this part is A, and this part is B. And when I start, A is going to be 0, right? And so if I say A is 0, what are the values of B? Again, there could be a lot of them that work for B, right? But now if I set A to these values, increment A by these values, slowly there'll be fewer and fewer that actually work, right? And so that's all I'm doing right here is I say, okay, append B to the end of A, and then simulate the program just for this one iteration, right? It only happens once because I want to know what that one position outputs, right? And so if for this first one, it's like, hey, what do I get if I set A to 0 through 7? And is if it's ever the value, the literal value 0, then I can add that to my thing. And the first time, again, there's probably several of them. But you notice here, the simulate group, I'm not actually running the computer program. You could potentially run the computer program, but I just took what I had written over here and turned it into like real code, right? So I said, okay, well, let B be a modulus 8, and then B is B XOR 3, and then C is A divided by 1 shifted B. This is what I think I told you about earlier. It turns out that 2 to the power of n, right? If you've heard about that before, if you've thought about it in a bitwise way, that's really just you doing a bit shift of the value 1, left shifting 1 by that value. So I just do A by that. And again, this is the one that has, at least in my code, it has the effect of truncating A by B. So C is the bigger truncated part, and B is the first 3 bits. But now I've XORed it with 3, so it's not the original B, if that makes sense. Notably, you reverse it here. So part of me was wondering, if you're reversing it here, is there something I'm missing about what's going on here? Like if you think about B XOR N XOR B is N. I don't know if you I hope I got that right. I think that is right. There, because of the way XOR works, is if you XOR the same value twice, you get, whatever was XORed with that original value, that value. So just to clarify again, B XOR 3 is B. And so the question is like, why are we doing this? Is that right? I kind of want to do this right now. Python. So like 5 XOR 3 or 4 XOR 4 should be 5, right? Yeah. Okay. I'm not dumb. Although sometimes I try to be. Okay. So again, I'm just running the program, and remember my output mod 8. We have to do mod 8. So we do the mod 8 here for the output. So I just simulate the loop. I fake it. I say, here's what the program should do. And if I ever get a value, I add that to my stack. And then I just do that recursively, right? And I'm slowly working my way down until I find, sometimes it will go back and say, oh, that path didn't work, so I have to try another path. And it'll say that path didn't work. But eventually I'm got to get to one that says, oh, I found a 2. And it's going to be... it will be the answer, right? Because now I found a value that is literally all of them. I do think I have a bug in here because there's a potential for, I actually don't think there is. Like, I don't know if there's a unique, how do I say this? I haven't tried to prove that there is a unique solution to this question of like, how do you run this program and get this value? But I suspected it was, and it turned out to be the case, that once you got here to the end, you found the solution. So this is like yesterday what we talked about. If you think what I'm doing here, I kind of am doing like a Dijkstra's, except I'm using a queue because I'm more interested in like the longest paths type thing. And so I'm focusing on the ones that are the longest path in solving this problem. And but the general idea is I'm going to try and find them until I find exactly the one. If it is the case that is not a unique solution, my guess would be is like I would just have to keep doing this until I found all of them, and then I would just pick the minimum one. But my intuition is that's not the case, and there's only ever one, though I can't say for sure. Um, yeah, I don't think you could, because, and you could verify it because like the simulate loop would like return the same values. Anyway, mm, I don't know how you could prove it though, but that was my intuition, and it turned out to work. So, if you can find something wrong with my like thinking and logic of that, I'd love to see it. But this is what ended up being the solution, and I thought it was very cool. Um, Again, it's nothing like part one, and so maybe you don't like that, but I had fun trying to figure it out. Um, I think it was a crazy like solution to a problem is to say, oh, if I look at the problem and I can kind of see what's going on and kind of get the understand the what is happening here, I can see that I can break it down. And I realize this looks like the madman thing now, right? I'm the but like I did get there, and I don't know, maybe I presume other people have a bunch of scratching like this trying to figure out what's going on. Um, it's actually really hard to do this thinking too when you have interruptions by like kids and family and activities and stuff. So I felt like, okay, well, I got the answer. I'm sticking to it. I actually a thought occurred to me is like, could you generalize this solution to all of them? I don't know that you could, because you have to do some analysis here and say, what is this program doing? I suspect that most of them are doing something like this, and maybe like what values could you change? Uh you could change these values right here to be any number between 0 and 7, right? Um cuz you're really just interested in these, and then the question is like how far are you shifting? And so there's a potential that like these two values, and oh well, and this value then too, right, is like how much of this middle area do you take would change. I don't think you want to do that. You probably can't change these. So we'll have to look. I would be interested to look at other people's outputs. I know you're not supposed to like share them or save them or whatever. Um, but it would be interesting to look at the different outputs and maybe see how different they are. And that might change the way that you solve your problem, right? For me, it ended up being, oh, well, I'm really only interested in like this chunk of B and the rest of A. And then like that helps me like figure out where the chunk is in here. It is different, I think, now that I'm thinking it through. Like this C ends up pulling different parts, but it's a different part of A. And so as long as you can like find different solutions for B that are acceptable for an A, eventually you get there, right? Um, so anyway, there's my chicken scratch. There's part two, and I'm definitely excited. I wanted to go look at solutions for this. I should say I did try and use the Z solver too, and that was a nightmare getting it to work in like Windows. Just I'm really used to Linux and you know how libraries and compiling works in Linux. And so, man, I did a lot of searching to try and get it to work. I did get Z3 to compile, but I could never get it to give me the right answer. So, and so I actually went looking for like other people who solved it with Z3. And I even looked at my previous day. I think I have this somewhere. Yeah, this one. So last year's day 24 is solvable with Z3. I think this was actually another day, and that's why I thought, oh, Z3 might be fun to try and do it. There's like this one was like I think it was a one where you're like, how do you throw a snowball so that it hits like icicles or something like that all the time? And so I was able to use the Z3 solver to do that. And I thought I could do something similar to it, but I could never get it to work. The idea behind the Z3 solver was like, uh, you say, hey, my variable is A, and then I'm going to run all these operations on A in a loop, mod 8. And I'm going to do it for, and each output of the values should be the output of the program, right? So like just like at a high level, the Z3 solution that was coming to my mind was your variable is A, and then you loop for each int in program. You guys can't see this, huh? Or you loop for each int in program, and then you run the sim, and then you assert that the output is the int, right? Is this value? And so you do that loop, and then you assert that A is equal to 0. Like that, right? This was my intuition for it, but then when I called the solve, it gave me like some number that wasn't even in the range I expected. It was like in the, I think it was in the, it gave me like a 1 trillion size number and not like a, I think it at least needed to be a 35 trillion or something like that number. Like the min was 35 trillion or something like that. So I could never actually get it to work. If you solved it with Z3, I would love to see that. So anyway, that's day 2. At a high level, before we go to the solution review, I can predict that some people will love this one and hate it, just like they have previous days, because not everyone likes this type of intuition solving, but it's in almost every, I think it's been in all years. Sometimes it's multiple days in the year where you have to go look and inspect your test to find some interesting thing about it. And so if you don't enjoy that, you can just skip these days, right? There's no problem with not trying to solve it. But I think it's a fun thing to try and inspect it. You basically are disassembling a program, figuring out how it works, and then finding something. And so if you've ever done like security stuff or things like that, this is like those type of ways that you go about solving it are the same, right? How do you figure out what the program's doing and find the things that can help you like get to some kind of vector of attack, right? And so this, I think these ones are really fun to solve. So, okay, let's go look at Intcode and see what everyone says in the Reddit. Not sure I'm helping else create a computer or if they're tricking me into reversing a hash function so they can do some cybercrime. Ooh, is it a hash function? I mean, you are doing a lot of XORs. Is it actually a hash function? I should refresh just to make sure. You are literally doing a bunch of XORs. I mean, it kind of is a hash, huh? Okay, very cool. Interesting. It's not a very good hash, though, if you can reverse engineer it, right? So I actually don't. I'll have to think about what type of hash it might be if it is one. Ooh, they used a GPU. Yes, because of all the XORs and stuff, this one definitely leans itself to GPUs. You could totally parallelize this. That would be fun. Although it still takes 6 minutes because you're doing like trillions of them. That means he's going to make the search space 100 times larger next year, right? Could be. I don't know. There's been days where the search space has been large and people have still figured out how to. I think I saw one time someone spent like $100 or something like that on some GPUs in like AWS or something like that to solve one of these problems. And they were like, oh, yeah, cool. Day 17, preparing for tomorrow's puzzle be like. Okay. This dragon book is really cool. I have not seen this cover, though. Is this like the original one? This is definitely a great book to read if you've not read it and are interested in computer science and programming. So, fortunately, it didn't take too long to fix, but for a while, this precisely captured my feelings. Hypertension, Stress migraines. Solution outputs the correct sequence, but the answer is too high. Oh no. Yeah, why would that happen? I mean, I guess it depends how I actually don't know how they solved it. Output, but as soon as I did, it was the correct answer. Each digit of output only depends on the last 10 bits of A. So start by looking at all the numbers from 0 to 123 and sorting them by their first digit of output, starting the last two. Okay, so this kind of feels like mine. Then from there, just keep finding all overlaps from the next digit of output, working your way backwards and appending 3 more bits at a time. Yeah, I think if you figure out. Okay, so it definitely feels like 2. The program is probably the same because it looks like a lot of people are saying, "Oh, you're interested in like chunks of digits." I think we all had B equals A mod 8, C A C equals A shift B. Mine was the opposite. Oh no, it was A shift B, right? Did I do that wrong? Is that why I'm? Oh, this one could be shortened, right? This is the same as doing a shift of the other way. What? Um, I don't know that it helps it run any faster, but yeah, that is the same. So C can include bits as high as 8 to 9. Yeah, but then the B equals B XOR C and then print B mod 8. Only the last 3 digits of C are important. If you look through most of the fast solutions, you will see them only searching for something where the most significant octal digit creates the last character of the output. Oh, you are doing it in reverse, so that's true. Is like, yeah, the most. Did I say that wrong when I was originally saying it? At the at the time, it's like the least significant, but you're shifting them over, and so it does become the most significant. Uh, this and in the end, my bug was trying to match a 0 with a 0. Okay, yeah, that's happened before. This is probably like a Python or something like this, right? This would not likely happen in Rust, or it would catch you, right? Oh, JavaScript would do it too, right? Have you seen BVD? I wonder if anyone actually has the BVD instruction in today's input. It was neither in the small test program nor in the example so far, maybe. The BVD instruction does not occur in any input. Good catch. Oh, is this Eric? This is the guy who made it. It's there because I needed an 8th instruction and pick something both trivially similar to the 2 other instructions and distract from how when I'm doing bit shifts in the input programs. I kind of want to see what he's replied to. Oh, very good. I don't share my solutions lest someone mistake it for the right one. Very good. I don't think there is a right solution for many of these. So that's awesome. There's no such thing as an official solution. Most puzzles have many different ways you can solve it. My solution there doesn't use CRT either. I have to look. I guess I have to look at this in context. What concepts are generally required to be able to solve all AOC tasks? BFS, DFS, Dijkstra's Chinese remainder theorem. Oh, CRT. Okay. Um, there's probably I actually haven't looked. My guess is there's probably days where you could do the math for it. But okay, we've definitely used Dijkstra's BFS, DFS, or any dynamic program, right? With memoization or tabularization. Have I talked about tabular? I think I've tried to solve them before with tabularization. Hmm. Often the leak code ones lean themselves towards tabularization because it's really easy to do like a 2D solve of some of them. Anyway, linked list, binary search, we've done interval arithmetic, GCD and LCM, bitwise, topological sorting, shoelace, we've definitely done. Priority queues. I mean, these are all okay. Sorry, I've gone on track here. It'd be really interesting to see what he says. The PVD instruction does not occur. I love Thief. Oh, that the game Thief? Okay. Let's go back to this. I don't think it was in mine. I mean, Eric said no, so I presume it's not. Genuinely enjoyed this. Part 1, build a computer to take the number of brute force. No. Input program, 16 numbers, 8 commands, easy to decipher. Work out what each instruction does. Realize there are only 0 to 7 possible values for each output. Get output for A. Work backwards. Multiply previous value by 8. Max 6 to 7 outcomes instead of 8 to the 16. Yeah, there's like you definitely reduce the search space, right? So there you go. What concepts are generally required to be able to solve a? Oh, that's what we just looked at. Today seems to be an easy day. You'll need to find a new value which you can initialize register A so that the program's output produces itself. Yeah. This is how I felt, right? I was so excited about the int code, and then I got here and I'm all like, oh man, no. I'm gonna have to like do the sleuthing. And I like the sleuthing, but I was in an int code mood, if that makes sense. Carefully read the problem description. Uh-oh. What did he miss? There's a lot of things. I remember what I missed. It was this output one. Is it's like, oh, the out function return calculates the value of the combo, returns the output. I was just like, oh, it returns the operand. But I kind of glossed over the modulo 8. I wasn't reading it close enough. And so initially I wasn't doing that, and I was getting really weird values. So definitely can happen. Brute force in under 11 minutes. After being smart, my initial solution, Julia ran. Brute force and Rust. Oh, he uses SIMD and Rayon. Okay, so he's using like a GPU and Rayon. Uh, ooh, that's cool to use regex for this one. That would definitely work to solve it or to like parse it. Part 1. Inline always get out. Mask splat. Mask shifter. Okay, so he rewrote the program. Uh, and then basically checked the values. Is that right? While I is less than program lang and split all out. Okay, that's cool. I mean, you're still brute forcing it, but he like rewrote the program so he doesn't actually have to do the instructions. And then like these type of things work pretty quick, right? In GPU. Find A to make your program output itself. Is this hacking? Yeah. Yeah, there are actually, I mean, now that we've talked about it, I wonder if it is a hash function. I just don't know what it is. Or, I mean, it's possible he just made it up based on some kind of hashing thing. Trying to visualize with a rich library. Okay, okay, so he's clearly, it must be that there's this like node style thing where you're like I was doing. You're kind of testing. Excuse me, it's late here. You're kind of testing the values, backtracking, incrementing past 7 until it works. It's not a bug if it produces the right answer. Huh. I need the hit me over the head type of hint. Okay. My first intuition was that since A is read one octal digit at a time, I can probably produce a solution one octal digit at a time. The issue is that as many as the last 10 bits of A can be relevant to the next step. Okay, so here's how you fix this, and I don't know if this makes sense, is like you just recognize that you don't always know what the rest of A is, but you can you can try those values of A and until you get to an answer, right? Like you'll know, for example, again, like I said, these maybe I go back to this thing. When you first start, I'll start over. When you first start, you just have like this chunk right here, and A is 0, right? So A is 0, and B is like just this little chunk of 3 digits right here, right? So it's just 3 bits. And you run that, you try all values of B for that. And you might say, and it might say like, oh, 101 works, 011 works, and 001 works. This may not be the case, but it'll say these are the 3 values that actually work for B when A is 0. And so then you just take all of these and you make them A, right? So now you're like moving down the tree, and now you say, okay, well, what if A is this, and what if A is this, and what if A is this? And you shift them, and you say, so these are your new A's. That's terribly drawn. This is your new A, and this is your new B right here, right? And now you're just going to test all the values for B here. And this is the one here, and this is the one here. And my intuition or what I suspect is what I believe to be the case is that like the more you do this, the fewer there are. So whereas this chunk produced like it may have been large, it may have been like 7 values. Once you've gone down like you're at a D15, it's quite possible that there's only like a single solution that actually gets you there. Again, I don't know that to be the case, but that would be my guess. So like the issue is that as many as the last 10 bits of A can be relevant, and that comes from like where was that? This operator right here, right, is like you don't know, because it's some module of B, and it's like shifted it by 4. You actually don't know what it is. It could be any of these. I don't imagine it's going to be any of these big ones. Yeah, because you're just shifting. I actually think that like you'll never shift it more than 7, and so that's where he's getting the number from. The number 10 from is you'll have your first 3 bits, and then potentially you need these 3 bits that are way up here at number 10 or whatever, right? But it actually doesn't matter what they are at the time, because you're going to test all the values of B that are correct from a previous iteration, and then slide those over, and they'll eventually slide over into that space, right? And there'll be some values where it just won't work and it'll ignore it. And so that's like the intuition that I think you need to fix. So he's definitely on the right track. I have code that takes 2 octal digit and tries to keep all starting values of A that produce them by looking for overlap. For example, blah produces 4, blah produces 2. So logically, blah should produce 2, 4, except that it doesn't in the general case. Yeah, so see, it's not going to actually do it because you're shifting those over. This part is correct. It doesn't work in the general case, but there will be some cases that it does work, if that makes sense. And so as you're shifting through, as you're like shifting through and building these things up, right? I don't know how to visualize this. I'll have to think about it. But the idea is you start with some small b and some empty a, right? Initially it's empty. And then now you're going to have that b is going to become the a, and you're going to have to like find what this one is, right? And then A is going to become twice as big, and you're going to have to find what B is. B may say, hey, what's over here, right? It may try and consult this part right here. But for this one, it will end up being 0. And maybe it works this time, but eventually you'll get over here and then it won't work, right? It just won't work. And so this path will eventually die. And eventually you'll shift over the right chunk that gives you the solution to all three of these for some B, and you'll just do that enough that eventually you get to the right answer. I hope that makes sense. I hope I'm making that clear. I was testing random numbers for the first two output values and found the overlapping are. Well, it doesn't. I feel like I'm on the right track. You definitely are. This is close. You got it. I think the easiest way to work your head is it's easiest to work your backwards from the last number in the list. When you're at the last value, every bit of A is 0 except the bottom three. So you just need to find every value between 0 and 7. Spits out the last value. Yes, perfect. This is a good way to say it. And if you think about what's happening, now that I think about it, you may not actually get these cases because, like, you're trying to find values, right? For this first one, you're trying to find a 0, and then you're trying to find a 5 and a 3 and a 5 or whatever. Like, it's quite possible that you could get multiple of these that work, but you're probably not going to get the one that's over here is probably not going to produce this value, I guess is what I'd say. Even if it does, though, you're still eventually going to eliminate it because you're shifting over enough that it just won't work. Oh, this person says they could do it forward constraints. It seemed much simpler to work back to forward. Yeah, they even say that right here. Okay. Very good. I kind of wonder day 7 modulo Python -10 modulo 8 Ruby. Oh, 10 modulo 8 is 6. 10 modulo 8 is 6. JavaScript 10 modulo 8 is negative. You're stuck. Go to Reddit. The second is how remainder is usually implemented. The first is sometimes Euclidean division is actually modulo instead of remainder. There is a difference. Yeah, so maybe that's the issue. Does Python just do? I think this was an. Why would you even get this though in your day 17? I don't think there were negative numbers, were there? Oh, were you using like an I32 or something like that? And over, I actually don't know. There aren't any negative. Yeah, there aren't any negative numbers there. Oh, here you go. Overflow in 32. Awesome. Yeah, what is the right answer of -10? It is the difference of are you doing modulo or are you doing like remainder, right? And there is technically a difference. In most cases, it doesn't matter. I guess for positive numbers, it doesn't matter. For negative numbers, it would. Small run times. Okay, let's look at this guy's. Hi, last year my collection ran all the programs in 62. Okay, here's his that runs all of them really fast. Should we just look at his day 17 and see if it even makes sense? Oh, he just like chunk pulls out the piece that he wants and sets the registers. Okay. Let's see. Exec. This is much more concise, right? Like you can see it's literally like it's like, "Oh, I just know how to do these things and I'll do them." Oh, I didn't think about doing these type of operators on those. That's kind of a cool idea. Quine. I actually don't know what a quine is. A fixed point of an execution environment when that environment is viewed as a function transforming programs into their outputs. I actually have not heard this term before. How is that? That takes no input and produces a copy of its own sort. Oh, this is what I was talking about. It produces a copy of itself. Yeah, that's exactly what this is. Oh, okay, so he knew the word that I did not know. It's a quine. The idea that a program prints out itself is a quine, right? So, although it's not technically a quine because you have to give it a, I guess. I don't know. It's still a quine, I guess. I don't want to be too pedantic about it. I actually didn't look how he solves his quine though. Let's see. He actually runs his program for each exec. Interesting. Is that what I'm seeing here? He actually runs the program for each a less than, so for the first 10, 2 to the 10 or whatever. Okay. So he runs it for each 2 to the 10. He must use this as like kind of a cache. Let's see what he does. Table, if table I equals text 0, cur append cur int I for int I have to grok this more. I don't have enough time and I'm sleepy. This is one I want to go back to though, so I'll make a note of it to see how they solve it. That's very cool though. Yeah, let's go to the daily solutions thread because that looks like a cool one. See if we can't find a couple before I drop dead. Language Python, nice simple little binary search through possible. What? Oh, day 18. What the heck? Are we already on day 18? I don't want to sully my experience. I don't want solutions yet. Day 17 solutions. It is. It's time. Okay. We'll see when we get this out. It is fun building the program to compile. So he says he has a generalized solution. Okay, I presume like oh. He's using Z3. Did I miss that? He is using Z3. Ooh, I'm interested in this. Okay, so this is a generalized solution. And it is actually generalized because he's actually saying he's like, okay, Z is an int and I was using a bit vector for BV. I was using this in mine. But then he creates the variables and he literally runs the program and probably does some asserts right here. So these are the asserts where he says, oh, these should be the case depending on the operations that you get for each of the steps, right? So you build a bunch of constraints based on your program running, n times or whatever, 16, I guess. Your program loops 16 times. So you just need to loop 16 times. And then you call check and get the results. Okay. I mean, I thought I was kind of doing that. I must have just been doing it wrong or not know how to do it in Rust. But I did find the bit vector sort. Uh, because I had like minimized the program, I didn't do I didn't have all these other variables. But this is really interesting. I almost kind of want to run it to see if it spits out the right solution. That's really cool. So like it uses Z3 and each instruction you run gets like put into the Z3 to like in the Z3 solver to like figure it out. I wonder how long it takes. Anyway, that will be one to go back to. If you solved it with Z3, I'd love to see your solutions. Let's just look at one more and then we'll be done. Yeah, that Z3 definitely came to mind. I tried to I tried to find a solution to it. I did not see this one. That one's better. All the when I tried it at first with just like I basically took this and did that for each of these values. I said the I should assert that this at the end is equal to, you know, whatever position these are. That many, and so I did that for all 16 of them and then tried to run it but could never do it. And I must be missing something. His way looks very cool, a more generalized solution. I would definitely love to see it if you did it that way. Um yeah. I mean, this looks like it works. It looks like it's almost doing the exact same thing I'm doing. Like I'm trying to figure it out, but it's like basically saying why I don't know why you do this. You just want to do like, oh, why are you doing 1 to 8? Isn't it 0 to 7 you'd want to do? Maybe I don't understand totally what's happening here. But you say, you know, you shift your A3 and you add your B to the end of it, and then you test to see if it outputs the correct value, the value you expect. And if it does, and it's the final value, you're done. First output. Yeah. Oh, this okay. So he does rerun the program, which is fine. I actually don't think rerunning the program takes a lot of time. It does if you're doing it a trillion times, but my guess is, oh, let's just see. Uh, I suspect this will be relatively small. 38. Wow, I actually didn't think it was gonna. I thought it was gonna be in like the dozens, or like the hundreds of dozens, right? Like is that even a word? Man, I am tired. I'm doing this really late. I apologize. It's like I don't know if I'll even get it out tonight, but I had a lot of family activities and stuff, and I was doing this in the middle of the day, and I was just like, I want to get the video done. So hopefully it's still a good video. Hopefully you still enjoyed it. But I think you can see like, wow, this is so much smaller. I only had to like do 38, right? Like I only had to traverse 38 solutions to get the 16. So like double the actual. That's crazy how quickly it finds it. Maybe the scope was actually smaller then. That's really interesting. But hopefully you've enjoyed this day. I am going to end it right here. We've talked about a lot of solutions. I would love to see if you did it in Z3 or if you did it some other way in Python or whatever. Um, this was the solution that worked best for me, And again, it's just about sleuthing and finding things, right? So if you loved that, today was a great day for that. If you're expecting the Intcode computer, you're probably a little depressed after part one. But overall, I think it was still great. I have not met a puzzle that I didn't love, even if I couldn't solve it. There's been days in the past where I just didn't know the answer and I had to go get help. But like finding those things, like I think I learned about the shoelace algorithm. That was one of the ones we'd seen before, actually from a previous day. And so even that made it cool, right? So anyway, I hope you enjoyed it. We'll be back tomorrow for the next one.